of reference. What is this one? All right, now this was photoelectric effect, and we say that photoelectric effect, this is the emission of electrons from a metal surface when an electromagnetic radiation of sufficient frequency falls on it. The name given to that sufficient frequency is what we call the threshold what? The threshold frequency. It is the frequency below which no electron is emitted. Okay. So we said that a photoelectric effect normally it is used in photocells, and also in phototubes. But when we look at photocells, we say that a photocell, this is a photocell. A photocell has got a zinc cathode, has got an anode, has got a glass tube, and inside the glass tube there is no air. It is a vacuum. Why is it a vacuum? Why is it a vacuum? Why is it a vacuum? Very fast. Why is it a vacuum? Members, unmute. Unmute. I don't want to speak alone. Unmute. So why is it a vacuum? A, B, BL. Who's BL? BL, can you give us the answer? Why is it a vacuum? Members, we are making a recap. Those people were there last time. West where you were there. Why do we have a vacuum inside? If you don't know, just say pass so that we can go to the next person.
Yeah.
Yes.
To enable the zinc. You said something about some rays moving to the anode and.
I remember. Also, I said the whole thing. Even I remember. Let me zoom in. So we said that it is made a vacuum. Now look at this. Look at this part here. Let me see where. Somewhere here. Let's see. The glass tube is evacuated in order to avoid collisions of the injected electrons with the air or gas molecules. Are we together? Yes, so that's why the tube is evacuated. So the glass tube is evacuated to prevent collisions of the electrons with the air molecules. And now what's the use of the cathode, the zinc cathode? The use of the zinc cathode is to produce or to emit electrons when the electromagnetic radiation falls on it. What's the use of the anode? The use of the anode is to attract the emitted electrons. To attract the emitted what? Electrons. Members, are you revising? Are you revising these notes? Members, can you unmute and respond when I ask? Are you revising the notes? Members, do you get me?
Yes.
Yes?
Yes.
Why is it that you are not responding? Are you eating, having breakfast?
No.
Okay, so you respond when I ask. Are you revising the notes that I sent to you? Okay, that silence means you are not. So members, can you start revising because you are doing your exams next year, and I think next year is March. Have you heard?
Yes.
So get serious. For us, we are serious and we are trying to do our best for you. So once the radiation falls on the cathode, on the zinc cathode, electrons are emitted from the zinc cathode and they are attracted towards the anode. Whenever we have a flow of electrons, the name given to this group of electrons that are moving at a very high speed from the cathode to the anode, the name given to the group of those electrons is what we call the cathode rays. So cathode rays is the group of fast moving electrons. So the electrons that the cathode rays that are moving from the zinc cathode are attracted towards the anode. And whenever we have electrons flowing from the zinc to from the cathode to the anode, there will be a current that will be generated in the circuit, and this current flows in the opposite direction to the direction of electrons. So this is what I'm saying, that if we have, this is what I'm saying. Let me first zoom in this. So I'm saying that if we have electrons, if electrons are moving in this direction, they are moving from, let's say this was the cathode, and this was the anode. The anode is positive, the cathode is negative. And here we have a bulb. That's the symbol for a bulb. If you have a bulb here, so we have electrons. These electrons are produced whenever a radiation, let's say ultraviolet is the radiation. If it falls on this cathode, this is the cathode. So when this radiation falls on the cathode, electrons are emitted. There will be electrons emitted, and these electrons are attracted towards the anode, So when electrons flow from the cathode to the anode, current is generated. Current is generated. So current will flow in an opposite direction. So we shall have current flowing in that direction. The symbol for current is I. So I means current. So this will be current flowing in the opposite direction of the electrons. So we shall have current flowing in this direction, and now the bulb will give light. Why is the bulb giving light? Because there is current generated. How is current generated? When the ultraviolet radiation fell on this cathode. This cathode emitted electrons. So emitted electrons from it. Electrons were being injected out of that cathode, and those electrons were attracted towards the anode. Once electrons move from the cathode towards the anode, current is generated. So members, this is what we call the photoelectric effect. Current is generated just from the radiation from the sun, let us say from the sun. That's how photocells work, that those photocells are in solar panels. They trap the light, they trap the radiation, and once they trap the radiation, electrons will be injected out of the cathode that is found in the photocells, and these electrons are attracted towards the anode. Once the electrons move from the cathode to the anode, current is generated and current flows in the circuit. And now if you have a bulb connected, the bulb will give off light. That's how you can see those street lights. They have solar panels at the top, and those solar panels are the ones that generate current for those bulbs to give off the lights. Okay, any question, members, before we proceed? If answer no, someone, class captain, you can say no, and we proceed.
No.
No.
Hey, okay. Let me ask you one question. Let me ask you questions. One, what's the use of the anode? What's the use of the anode? If no question, what's the use of the anode? Very good, Patricia. Patricia, thank you. To attract the emitted electrons. Very good. That is nice. We go to the next one. What's the use of the cathode? What's the use of the cathode?
To emit electrons.
Patricia, correct again, Patricia. To emit the electrons when a radiation falls on it. A radiation of sufficient frequency falls on it. What's
Teacher.
Yes? Put up the hand. Who's
Can
asking?
you say that, Shelley?
Yes, Shelly.
Teacher.
Yes.
What if you say that the use of the cathode is To reflect the ultraviolet rays to the anode.
The use of the cathode is to reflect? No, that is not the right thing, but that answer is the answer to this question. Why is the cathode made concave? Do you see this shape which is here? It is concave. So the cathode is made concave to reflect all the electrons towards the anode. That's the answer to that. But the usefulness of the cathode, why do we have the cathode? The cathode is to produce electrons when a radiation of sufficient frequency falls on it. Is it okay?
Yes, teacher.
And lastly, why is the vacuum evacuated? Who can give us the answer to that? Why is the vacuum evacuated? Mwesigwa, give us the answer to that. Mwesigwa. No, you are just there smiling, and we cannot even see you how you are smiling. Can you give us the answer, Mwesigwa? Mwesigwa, can you unmute? I don't know what is happening to Mwesigwa, but we looked at that the cathode is evacuated, the glass tube is evacuated. The reason is to prevent collisions of the air particles with the electrons. Now, conditions for photoelectric effect, we say that nature of the plate, not all plates can give off electrons. And also we looked at the frequency of the incident electromagnetic radiation. So the frequency must be suitable. And that frequency is what we call the threshold frequency. That is the threshold frequency. This frequency is the third frequency, is the suitable frequency below which no electron is emitted. So that frequency must be suitable for us to have electrons to be emitted. The frequency for the incident radiation, not all radiations. The light from your torch may not have the enough frequency to emit electrons from the cathode. So it means that the frequency of that radiation must be sufficient enough to emit off the electrons from the cathode. Now let us look at thermionic emission. Look at thermionic what? Thermionic. The word is
Emission.
yes, emission. Thermionic emission. What's thermionic emission? What do you understand by the term thermionic emission? Mwesigwa, you are forgiven, but please settle your cases with your microphone, okay? Okay. Now, what is thermionic emission? They are saying this is the process. Can everyone read that?
This is the process by which electrons are emitted from a metal surface by heat.
Correct. This is the process by which electrons are emitted. Members, for you to understand physics, for you to have physics moving in your bloodstreams, you must understand every word that is in that definition. You must understand everything that is there. Do you understand the process? Do you understand electrons? Do you know what electrons are? Do you know a metal? Do you know what a metal means? Do you know heating? Do you know the process called heating? For you to understand the general definition, you must understand every word that is there. That contributes more at your understanding this subject called physics. So the process by which electrons, we say that electrons are negatively charged. Members, can you unmute? Please, unmute. Unmute. I want to hear a class that is responding. We said that electrons are negatively what?
Charged.
They are negatively charged. Correct. They are negatively charged. So it's the process by which electrons are emitted from a metal surface by heating. We know the process of heating, isn't it?
Yes.
Heating, this is a process of what? Heating. What's heating? Who can process of what? Of increase in
Temperature.
increase in temperature. So increase in temperature by either using fire or by using electricity or using anything. So heating is the process by which the temperature of an object is increased. So that object now is the metal. Once we increase the temperature of a metal by heating that metal, what will happen? Electrons will be emitted from that metal surface. Electrons will be emitted from that metal surface. And the stream of electrons are transmitted or travel in a straight line. And this stream of these electrons is known as cathode ray. Cathode rays is known as cathode rays. So we write the definition there. As you are summarizing, the definition must be important. If you have not written the definition, please write it. Is the process by which electrons are emitted from a metal surface when heated, full stop, when heated. Now, when a metal surface is heated, it produces cathode rays. And what are cathode rays? Cathode rays. And what are cathode rays? So we are now summarizing these notes. Cathode rays are streams of fast-moving electrons. Full stop. Streams of fast-moving
Electron.
Of fast-moving electrons, streams of fast-moving electrons. So let us look at how a cathode ray is produced. Before we look at this explanation, let us look at a video and we see how a cathode ray is produced. So let me first put here cathode rays. Look for the nice video. Cathode rays, cathode rays, cathode rays. Yeah. Let us look at this. I think everyone is seeing, is going to see. Are you seeing this?
Teacher.
Yes, you may. No, not this one. This is an advert, members. Not this one. Waiting this internet connection. I think it should do. They should make internet to be free. Of course, we are not into that. We are into this. I'm the one who's explaining, members. So let me explain. Now, there. This is a cathode. Are you seeing that kind of brown thing? Let me take it back. Let me take it back. Come on. Let me take it back there. I'm the one in charge here. Okay. Very good. Now, this is a cathode. This one. Only that is all yellow, brown is a cathode, and this one is a filament. It's called a filament. Now, the use of the filament is to heat the cathode, is to heat. I'm saying heat with H-E-A-T, to produce fire, is to heat the cathode. So we said that cathode rays are produced when a metal is heated. Now, our metal is the cathode, and this brown thing is the cathode. So this is the filament heating the cathode, and the filament is connected to a source of voltage here or power. This is power or a battery to heat, and once it is heated, it's going to produce heat and it heats the cathode. So the cathode is negative and this is the anode. That one was the anode. So So now there is a high voltage that's supplied between the cathode and the other side, which is the anode. When the cathode is heated, electrons are going to be emitted. So these are the electrons which are emitted. And these electrons are negatively charged. They are negatively charged. So negative electrons are going to be repelled. They are going to be repelled from this cathode and they are going to be attracted towards the anode. This is the anode. So these electrons, if I pause there, these electrons that you are seeing moving from the cathode towards the anode. Why are they moving towards the anode? Because the anode is positively charged. It has a positive charge because it is connected at a positive terminal. If I may take you back, it is connected at a positive terminal. This anode is connected at a positive terminal. You do not see much about the anode, but let me show you. There. That is the anode at that point. That is the anode. It is connected to the positive. So it is connected to the positive and the cathode to the negative. But in between them, there is a high voltage. There's a high voltage. The use of that high voltage that is connected between the cathode and the anode, the other side, is to accelerate. The word is to accelerate. To accelerate these electrons which are being produced. So the electrons are produced from the cathode and they are accelerated towards the anode by a high voltage. That high voltage we have seen it down there, which has positive and negative. So once those electrons are produced from the cathode here, after the cathode being heated by the filament, these electrons are accelerated and they are attracted towards the anode. Now you should know that inside it is a vacuum. Inside it is a what? It is a vacuum, and inside there is no air. Why don't we have air inside there? Is the same answer of photoelectric effect. Do you remember the answer of photoelectric effect? Why the tube is evacuated?
To prevent collision with air particles.
Very good, Letitia. To prevent collision of the air particles with the electrons. So that's why the tube is evacuated. Now those electrons flow from the cathode towards the anode, accelerated by the high voltage, as we are seeing there. Good.
Excuse me, Chair.
That's the end, yes?
Chair, I was not hearing clearly. What accelerates the electrons being produced by a high voltage?
What accelerates the electrons towards the anode is the high voltage. This high voltage, are you seeing it? Let me show you. Let me show you, and then you see. You cannot hear the words because I'm using the microphone. So this is the anode. So they are connected. You see, there is a high voltage here. This is supply. If the cathode is heated, electrons of the metals are emitted. And they are repelled from this cathode. Because the cathode is negative and electrons are also negative. So that's why the electrons are being repelled. But they are repelled towards the anode. And now inside, it is a vacuum. It's a vacuum to prevent collisions of the electrons with the air particles. The high voltage accelerates those electrons at a high speed towards the anode. Good. We shall not see what this gentleman will, what this gentleman was saying. So let us go back to our. Come on, let us go back to our exercise. So a cathode ray. So this is a cathode ray. Are we together? This is a cathode ray. So inside the cathode ray, if they tell you to draw a cathode ray, don't do the other thing that you have just seen, no? Come and draw this, what you are seeing here. So there is a cathode, this is the cathode. There is the anode here. Here there is a bulb. Now in the other one, we do not see the bulb. So I'm going to show you the one which has a bulb. And this is the filament. So let me just show you the one which has a bulb. And then we... Okay. Call it a cathode ray oscilloscope. Cathode ray oscilloscope. Let me try and see this one. Of course, not that video. This is another one. Members, are you following?
Yes, teacher.
So you follow. I want you to first. That is, members, this is a cathode ray. This one is a cathode ray oscilloscope. If you have seen it, you have not seen these things, but when you, I shouldn't say when you grow up, but when you study up to higher levels, up to the university, you'll be able to see these cathode rays. But these cathode rays also, we have already seen them. They're in hospitals, they are there. So this is how it looks like, but what is inside? So let us see what is inside. Okay, you are not hearing, so let me try. I don't know, let me put the microphone on the speaker and see whether you can hear. And I put the microphone here. Are you hearing something? Are you hearing something?
No?
You're not hearing anything.
Somehow.
Wow.
Look at those plates. We have the white plate and the X plate. Look at them very well. So that is the screen. Let me take it back because you people were not hearing anything. Were you hearing?
Yes, teacher.
Someone, Alexandra was saying, is not hearing. No. So let me explain for you. So the cathode ray oscilloscope is made up of three main parts. So now it has three main parts. Let me explain for you. So it has one, this side where we have the, let me start from here. It has what we call the electronic gun. The electronic gun. So the electronic gun has got the filament, it has got the cathode. This is the cathode, the one which is red, and it has got the grid. This one is the grid, the one which is in yellow. It is called a grid. Then this one, this is what we call the anode. Kabami, can you unmute? I mean, can you mute? Kabami, making noise for us. So, the cathode ray oscilloscope has got 3 parts. It has got the electron gun. And in the electron gun, we have, take note, in the electron gun, we have the filaments, the cathode, the grid, and the anode. Are we together?
Yes.
Yes.
Teacher.
Now, the other second part is what we call the deflecting system. The deflecting system. The deflecting system, we have the Y plates. These ones where I've put the cursor. This is the Y plate and the X plates. The Y plates around which are up and down, the X plates around which are left and right. That is the deflection system. It has the last system, which is called the fluorescent. I mean, the last part is called the fluorescent screen. Fluorescent screen. So this is the fluorescent screen. This fluorescent screen glows or gives off light whenever electrons strike on it. That's the fluorescent screen. So members, when you come back again, I'm going to use this same video to explain to you the cathode ray oscilloscope, how it works and how electrons are being injected from the cathode up to the screen. So a break of 5 minutes,
Sure.
of 2 minutes. Yes.
The function of the fluorescent screen.
Okay, I'm going to come back because I don't have enough time to explain that. I'm going to come back and explain every function for each part.